This is A-Level Mathematics. We're going to be working on chapter 19.5.2. On this problem right here, we are, for the differential, dy over dx is equal to xy over x squared plus 1. Find the equation passing through this point and the general solution. So starting with part A, so I'm going to take my dy dx is equal to xy over x squared plus 1. And to this, I need to try and move my y's over here because I want to do this in terms of my x because that's what it says. So it says my equation, okay, in terms of x, so I'm going to move my y on the other side. I'm going to multiply both sides by 1 over y. So I'm going to get 1 over y times dy dx is equal to, so after I cancel out that y, I'm left with x over x squared plus 1. Now for this right here, let's go ahead and integrate both sides. So I'm going to set this up. So for the right hand side here, this is going to be an easy. This is going to give me ln y. But this one over here, this one is not. So I'm going to do a sub. So I'm going to say that my u is equal to, let's say, x squared plus 1. So when I get my du is equal to the derivative, which is going to give me 2x dx. Now I'm going to substitute here because I'm going to divide by 2x. So let's see what I have here. So now for this, let's rewrite it. 1 over y dy dx is equal to, so this is going to be written as u on the bottom, x on top, times what I have over here, which is going to be my 1 over 2x du. So I did this one right here, and that's going to replace what I have here. So now my x are going to be able to cancel out here. So I'm going to rewrite this again. Let's rewrite it. I have 1 over y dy dx is equal to, those cancel, I'm going to get 1/2. So that's my 1/2 here. And since it is a common factor from this, I'm going to actually pull it out and put it in front. So it's going to be in front of my integral. And that's going to be the reciprocal of this. No, not the reciprocal, I'm sorry. It's going to be the 1 over u, because that's all that's going to be left here. 1 over u du. So for this one here, now I could do the integration of this, I could do integration of this, so now they're actually going to be both pretty simple integrations. So I'm going to get ln y equal to, is going to be 1/2 ln of u plus k. And now for this, I'm going to plug my u's back in. So it's going to be ln of y is equal to 1/2 ln of x squared plus 1 plus my k. Now, right here, if I look at this, there's no possibility for this ever to be negative. So the absolute value is going to be unnecessary, but I'm still going to write it. So I'm going to write it so we don't lose this one anyway. So just to make sure that it is possible for this one to still be negative, okay, there is limits on this one, and then this one right here, it's always going to be positive. So you could think about that when you're actually doing these problems, that whenever you're looking at something and you say, oh, look, absolute value goes away for some reason. But this one, it's not possible for it to ever be negative. Now, let's take a look. And so now I have this one and this one here. So I'm looking for the equation where it's passing through this point here. So let's go ahead and plug in for that point. So it's going to be ln, and so that my y value is 2, is equal to 1/2 ln, and that's going to be my x value. If you see right here, my x value is 1. So it's going to be 1 squared is 1 plus 1 is 2, ln 2 plus k So let's go ahead, put these over here. So I'm going to subtract it. So they both have the same ln, so think of it as a common variable here. So when I subtract it here, they're going to be the same. So I'm just going to combine what I have in front. So there's a positive 1, and when I move this over here, it's going to be minus 1/2, which is just going to leave me with 1/2 ln2 is equal to my k. So now I can put my problem together. So I have my k value. I actually have all my value here. So let's go ahead and plug that in there. So I have ln y. So ln y is equal to my, where am I at over here? Right here. 1/2 ln x squared plus 1. And I'm going to be adding my 1/2 ln of 2 to this one because that's, I'm sorry, my plus sign here. That's going to be my k value. So I have to add that there. All right, let's go ahead and do some combining here. So when I do the combining, let's take a look. And when I combine these together, I'm going to end up with, since this is a plus sign, it is a plus sign, so it means that I'm going to multiply. If it was a minus sign, I would divide, but this one I'm going to multiply. So I'm going to have, let's see, ln of y is equal to, so ln of is going to be 2 quantity x squared plus 1. And I'm going to close that there. Now, there's a 1/2 in front of the ln. So anything, any constant numbers are right here in front of my ln, because of my rules that I have for my ln is that that can go for my power. So that's going to be to the 1/2 now. So what I'm doing is I'm combining all of this together here. So I'm going to have a 1/2 right there. Now, from this one right here, let's take a look and look. I had the equation, so now I'm going to get the equation for the y equals 2. So I found out where it was at, this is where, okay, equation passing through that point. So I plugged in those 2 points, and this is the equation for that point right there. So this is the answer for part A. So if you see that, that's the equation for part A. And the next part, I'm continuing. I should have stopped earlier and actually pointed that out. This is the equation passing through point A. Now the general solution is, I want to make it into y equals. So that's what I did this right here. So now I'm going to make it into y equals for this one. Okay, so right here, these are both combined together. So this is either or of these I'll accept for answer for A. So if you're combining this, this is fine. Now the next part right here is where we're going to get, we're going to try and get y by itself. So if I notice, I isolated all this over here. So when I do my e, because I'm going to e both sides of this. So when I do e, I'm going to be left with, let's see, y is equal to, let's see, that's going to give me 2 quantity x squared plus 1, close, close, and that's to the 1/2. So now I got it down to my y equals, and so therefore that is my general solution. So that is going to be my answer for B. Alright, now on this next problem, it is 19.5.3. Now, long word problem, and I'm going to read it out for you, and I picked out all the important information already. It says, for a certain period, about 12 years, the rate of growth of a country's gross national product, GNP, I'm sorry, this is, they use N instead of domestic product, sorry, so GNP, is predicted to vary between 5% and -1%. This variation is modeled by the formula of quantity 2 plus 3 cosine 1/2 t percent. That's important to have the percent there. Where t is time in years, find the formula for the GNP during the 12-year period. Now, with this, let's go through and denote that we have our equation for this is going to be d of p over d of t, which is terms of time, is equal to 2 plus 3 cosine of 1/2 t. Now, if it's in percent, let's change it out of percent so I could actually do this one here. So out of percent is going to give me out of 100, because percent is always written out of 100. So I'm changing it out of the percent to an actual fraction here. And so I'm going to have times whatever my p is here. So p is going to be my constant variable that I have here. Now, let's take a look. I'm going to move this to the other side of the equation. So if it's times the p value here, so what I need to do is I need to divide by p, right? Or multiply by 1 over p, and that's going to cancel that out there. So I'm going to be left only in terms of t on this side of the equation. Let's take a look. So bring this down, 1 over p dp dt is equal to 2 plus 3 cosine of 1/2 t, and right here, there we go, over 100. Now, let's go ahead and take a look at this. I'm going to go set it up so I could do the integration of both sides here. So, integration of both sides. So, let's take a look. I'm going to put, this is going to be 1 over p dp dt equal to, factor out of 100, integrate, and that's going to be 2 plus 3 cosine 1/2 t, and that's going to be in terms of dt. Alright, I could just do this one straight across, and I could just do this one, so that's going to be ln p. ln of p is equal to 1 over 100 times, now integrate this, it's going to give me 2t. Now this one right here, so integration of cosine is going to give me a positive sign. So a positive sign of my 1/2 t. So now I left some space to put in what I'm doing here. So now I'm going to divide by 1/2. So this goes, I'm dividing by that. So if I'm dividing by 1/2, that's the same as saying I'm going to multiply by 2. Dividing by 1/2 is the same as saying multiplying by 2. So I'm going to turn this into a 6, and there, plus my k. There we go. Alright, so now I have all that set up here. Now, a couple things are given to me, and it was, let's take a look, that we have p has a value, my initial value of 0, or p sub naught for this case. So whatever my initial value is, whatever I'm starting off with, I'm going to call that one my p sub naught. So let's see, p sub naught is equal to my p, and then the t for this is going to be 0. So starting out, so it's whatever my value is, my initial value, my p sub naught, and this is my time is 0, so that's when I'm starting this. So let's see, I'm going to have ln of p sub naught is equal to, now let's take a look. So this is going to be 1 over 100 times, now this is 0, so that goes away because when I plug in 0, that's 0. Now sine, so 0 times 1/2, so sine at 0 is going to be 0. 0 plus 0, that all goes away right there, and it's times 100, and that's going to be, leave me only my k value here. So my ln of p sub naught is my value for k here. Now we have this, so let's go ahead and plug it back into this. So it's going to be my ln of p is equal to 100, 1 over 100 quantity 2t plus 6 sine 1/2 t, and that's going to be plus my ln of p sub naught. Now, right here, I'm going to put this away for the absolute value. It's actually going to go away on this one because our initial value should be a positive value out of this. So let's take a look right here. So the question says find during a 12-year period. So let's go ahead and take a look at what we have. Let's keep going with this. So if I have this in this form right here, I can, let's see, what can I do with this? All of this right here. So let's go ahead and do some combining for this. So I'm going to have that for e'ing both sides right here. So it's going to be times whatever I have here. So it's going to be ln. So that's going to just give me my p is equal to e of all of this, which is going to be 1 over 100 times 2t plus 6 sine 1/2 t there. And now since it was right here, so it was plus this value right here. So this value here plus that value right here, it is going to be still the same rule, so it's going to be a multiplication. So this one's going to go away and it's going to multiply by this. And I'm going to actually write it in front of this because otherwise it's going to get lost out here in front of that, or after that. So it's going to be p equals p sub naught, which is my initial value, times e to the 1 over 100 quantity 2t plus 6 sine 1/2 t right here. So that's what my what I'm going to actually end up with for this equation.